everyone! Today we'll go over some code structures and terminology that are shared across a lot of different coding languages. The goal of this video is to provide a foundation in common structures so deciphering and writing code might be a little easier. If you've coded before, some of these might be familiar. Before we get started, there are a few terms we'll be using quite a bit. Let's go over them now. First is pseudocode. Pseudocode is when you write out your code in sentences like normal speech. It's a way to think through what you want your code to do without jumping straight to proper notation. Next is functions or methods. Although the terminology differs across coding languages, functions and methods are the ways we communicate with our code objects. A function is a group of lines of code that can be called or used elsewhere in our program. Next is parameters. A parameter is a kind of variable we use as input for a function we write. The actual value of a parameter is called an argument. In the example below, color is our function. It has 3 parameters, one value for red, blue, and green. To get pure blue, we'd use the arguments 0, 255, and 0. When writing code, you'll generally define all your variables and objects at the top. These are the things that you'll be using or commanding later on in your code. We'll start with an example. Say we have a goldfish named Sandy, and we want to move them to their castle. In pseudocode, this would be tell Sandy to swim 4 squares to the right. Now let's take a look at how to translate that into code. I'll use Arduino, which is based off of C++, for my examples, but it would look very similar in Java. To get Sandy to move, we'll need to give them a command. For Sandy, let's say we've written a function called swimRight. SwimRight moves Sandy to the right by whatever number the argument is, entered into the parentheses. To communicate with our fish, we'll use the basic syntax sandy.swimRight4. This calls swimRight on Sandy and says to swim 4 squares to the right. Now we've gone from tell Sandy to swim 4 squares to the right to Sandy swim right 4. If we imagine this and plot it out by hand, we see that Sandy makes it to the castle. But say we wanted to do something more complicated. There are a few code structures to know. An if statement is a conditional statement. If the condition, or Boolean, is true, the code within it is performed. We put the condition we want to check in parentheses behind if, and all the code dependent on the condition goes on lower lines between curly brackets. If the condition is true, the code in the body of the if statement is executed. If it's false, the code in the body is skipped. For example, let's say we need to know how many apples we have in a basket. We know we need at least 10, so our pseudocode would look like this. If there are fewer than 10 apples in the basket, have the system display not enough apples. When we write this out with our code form, it's if apples is less than 10, then have the system serial.println display not enough apples. Remember, the code I'm writing here is using Arduino, but it'll look very similar in other languages like Java. See? But we can make this even more specific. If we want to do 2 different things, depending on if our condition is true or false, we can add an else clause. For instance, we can make it so that once there are 10 or more apples, the system displays enough apples. This is what our pseudocode would look like. If there are fewer than 10 apples in the basket, have the system display not enough apples. Otherwise, display enough apples. Written in code, if apples is less than 10, display not enough apples. Else, display enough apples. If condition 1 is met, then the code beneath condition 1 is completed. If condition 1 is not met and condition 2 is met, then the code underneath condition 2 is completed. Let's walk through this. 0 apples is not enough. Same with 1, then 2, 3, and so on. 9, still not enough. 10, the display changes to enough apples. 11 is also greater than or equal to 10, so it stays enough apples. We can keep going. If we want more conditions, we can add an else-if clause. For instance, what if we needed to know exactly when we had 10 apples? We can model it this way. If there are fewer than 10 apples, display not enough apples. If there are exactly 10 apples, display 10 apples. If there are more than 10 apples, display too many apples. And in code, we have if apples is less than 10, and that condition is met, print not enough apples. Else, if apples is equal to 10, print 10 apples. Otherwise, anything else, too many apples. So our first condition is if apples is less than 10. Our second condition is if apples is exactly equal to 10. Our third is if apples is greater than 10. So to break this down, if condition 1 is true, only block 1 is executed, and then we end the statement. If it's false, and condition 2 is true, then only block 2 is executed, and we end the statement. If condition 1 and condition 2 are both false, then we move to condition 3, and only block 3 is executed, and then we end. We can also nest these statements as needed. So for example, if the Makerspace is open, and if the student has safety glasses, the student can build their project. Else, if the student does not have safety glasses, the student goes to the library. And if the Makerspace is not open, the student also goes to the library. We use loops for repetitive code. There are two main kinds we'll talk about, and we'll use the same example for each to illustrate their differences. First is while loops. While loops check the condition before executing the body of the loop, and they will keep looping indefinitely while the loop condition is true. Make sure your loop condition can be false, or you'll make an infinite loop and your program will freeze. Let's bring back Sandy. Sandy needs a certain number of fish flakes every day. We estimate that each shake of the fish flake container releases 5 flakes, and they need 20 fish flakes. We start with 0. If we were to write this as a while loop, this is what it would look like. We have some integer variable called flakes, and we start it as 0. And so while flakes is less than or equal to 15, we increment flakes by 5. Now this example is a little confusing to look at, but here's why I brought it up. Especially with loops, if you're unsure if you've written it right, walk it through by hand. It will be your best friend. So we initialize flakes to be 0. Is 0 less than 15? Yep, so we give Sandy 5 flakes. Now, our number of flakes is 5. Is 5 less than 15? Yep, still good. So we give Sandy another 5 flakes. Now flakes is 10. Is 10 less than or equal to 15? Yep, so Sandy gets 5 more flakes. Now flakes is 15. Is 15 less than or equal to 15? Still yes, so Sandy eats 5 more. But now flakes is 20. And is 20 less than or equal to 15? Nope, so we exit the loop. And Sandy does not eat the next 5 flakes. Another common code structure is a for loop. Usually, a for loop will repeat a body of code a set number of times as tracked by the loop counter, which is usually I. After completing the loop body each time, the loop counter will update by our update expression. So here's what it looks like. For some initial value of our loop counter, we check the loop condition, and then at the end of our for loop, we'll update our loop counter by something we've chosen. And if the condition is met, we execute the loop body. Revisiting our same Sandy problem, let's see how we would write this using a for loop instead. In this instance, I'm using I as a counter. Each time, the computer checks if I is less than 4 because we only want to shake the container 4 times. If I is less than 4, it shakes the container 1 time, releasing 5 flakes. Once I equals 4, it will exit the loop. Let's look at another example to get some more practice. Say we want Sandy to swim in a square around their castle. We could write this using a for loop. Our pseudocode is for each of the 4 sides of the square, have Sandy swim forward 2 squares, then turn right by 90 degrees. We'll follow this path. Writing this in code, we have for counter equals 0, comma, the condition of I is less than 4, increment our counter by 1, Sandy, swim forward 2, Sandy, turn 90. Animating this, we can see Sandy make their trip. We start with I equals 0, which is less than 4, so Sandy swims and turns. Then I equals 1, same thing. Then I equals 2, then I equals 3. I equals 4 isn't less than 4, so we exit the loop. Now that we've gone over the 2 loop structures, when should we use one or the other? We typically use for loops for things that are definite, like counting and math. Wave the robot arm 2 times. While loops are great for when the loop condition can be false at any time, like in a game, such as while spacebar is pressed, do blank. The main difference is that a for loop has a counter. To review, we went over if statements, else/else if statements, while loops, and for loops. They all rely on a condition. If the condition is met, the rest of the statement or loop is executed. Here's one last look at the basic outline for each structure. Now let's code some cool projects. Thanks for watching!